Name of the product, beta. If you take what?
Ethanoic acid.
This is called acetyl chloride. The name of this one is called acetyl chloride. Common name it is, or ethanoyl chloride. Ethanoyl chloride. Ethanoyl chloride. Acetyl chloride or ethanoyl chloride. So definitely they will give what actually here. You have to break here. Ethanoic acid is formed. In this way, you write for this one 2 or more examples by taking what different number. You take next time propanoyl chloride like that, isobutyl chloride like that. You will get number of products here. Similarly, when you do basic hydrolysis also, in this case, first we in acidic hydrolysis what happened? First we add H plus, and basic we add OH minus. But both the case what happened? The product is what? Same only. Here it is the same product. Here it is the same product, isn't it? Next thing, if you observe what happened, anhydrates. How anhydrates are converted into carboxylic acid. Let me see this one. How anhydrates are converted into carboxylic acids. Now we'll see what happened. R, C, double bond O, C, double bond O, R. This is called actually what? Anhydrates, acid anhydrates, right? Acid anhydride, right? Now when you do again hydrolysis reaction, means we are adding H plus and OH minus here. Now you can break anywhere. You can break here or you can break here also. You can break here also. Okay, I am breaking here the bond actually. Now when you break here, what happened? This carbon is positive charge, no? This carbon is positive charge, no? Because it is negative character. Because of oxygen is more electronegative, carbon is what? Positive character. Now OH minus attacks where here, right? And this bond is taken by whom? Oxygen, and H plus is taken by whom actually? OH. So because of this, what product you are going to get? R, C, double bond O, OH, right? This one you are going to get R, C, double bond O, OH. And here, this part if you observe, R dash, isn't it? C double bond O, and we are going to get OH. R dash C double bond OH, R C double bond OH. Two products we are going to get. Both are what actually? Are carboxylic acids, right? So this they are writing like this here. They are writing like this. Both are what? Same only. So in the place of R, what they took here? C6H5. I am writing here, you observe here. C6H5, isn't it? C double bond O, again oxygen, again C double bond O, C6H5. Same thing only they taken. This one, benzoic anhydride. Instead of writing like this, if you write like this, what happens? It's very difficult for you to make the product. Now, if you write same thing, C6H5CO taken 2 times. You see C6H5CO taken 2 times, one oxygen is here. Now, again, break this bond over here. Put here OH and put here what happened? Hydrogen. You will get 2 moles of what? Benzoic acid. Right. If I take whatever different things, here it is different, here it is different. That means here it is different, here it is different. In that case, what happens? In that case, what happened? You observe here. C6H5, no. I'm taking what here? CH3 I'm taking. I'm taking here what? CH3. In the case of that one, I'm taking here CH3. Now again, what we get? This part. I'm breaking over here. You can break here also, you will get same problem, no problem here. So what we are going to get here? C6H5COOH. You see, C6H5COOH, and this part will be CH3C double bond OH. CH3C double bond OH. Now, if you make like this, then it will be easy for you. Otherwise, if you do write like this, what happen? It will be difficult. So what I mean to say in this case, RC double bond OCl, you practice in this manner. You practice in this manner. RC double bond OCl. And acidic anhydride, no, anhydrates, you practice in this manner. You have to practice in this manner. Okay. Now definitely you will get the products in that case. It's very simple. Break this bond over here. You add OH here. You add H. You will get the answer. So this is about what? Hydrolysis of acid chlorides and generally acyl halides they say, but generally we'll take acid chlorides only. You don't take generally acid bromide. If you take acid bromide also, you get the same product. No difference. Now, next thing is that from esters, this is what very, very important reaction for us from esters. Very, very important for us from esters. Now here, I will make very simple, same like this. Esters also will do this. Same like this will take action. So what I am taking here, ester I am taking. Any ester. So I have taken general ester I am taking here. All of you please listen here. R, C double bond O, O R dash. I am taking R dash means what happened? Both are different. If it is methyl, it may be ethyl like this. Both are what different like. Now, if you do hydrolysis reaction, so when you do hydrolysis reaction here, you have to add a base to this one, OH minus. Okay, OH minus we are adding. Here it is there, no, NaOH is there. See, NaOH is there, right? Now here thing is that this can be done with what? Acidic hydrolysis and basic hydrolysis. Or you can add H plus also, or you can add H plus also. That means if you add H plus, this is called what? Acidic hydrolysis. Acidic hydrolysis, basic hydrolysis. Now what happens here? How to make the product? Here we have to break compulsive bond. Here only we have to break. Now what we are adding? OH minus over here because carbon is positive charge and H plus to where? Oxygen, because oxygen is a negative charge. So what we get here, beta? R, C double bond O, OH plus R dash OH. That means we are getting alcohol plus what we are getting? Carboxylic acid. Carboxylic acid. So what are the products present in the hydrolysis of ester? See, acidic hydrolysis of ester gives directly carboxylic acids, while basic hydrolysis gives carboxylates, which on acidification will give carboxylic acid. What is the reason actually? See, actually here also we get carboxylic acid only. But see, you are adding base, no? When you are adding base, what compound you got, beta apple? Which compound you got here? As a product? As a product, which compound you got? Which compound you got? Are you sleeping? Which compound you are getting here in this reaction?
Carboxylic acid.
You are getting acid. What about remaining one? They don't speak anything. So you are getting what? Acid. So what you are adding in the reactant side? Base. Now base and acid, they can react together. So that is this when react with base, which is a reactant side. Product side, when they react with reactant side of base, so what happens? This OH minus and H plus will react here to form water. So this will convert into RC double bond O minus. Again, if you add H plus to this one, you are going to get same thing, RC double bond OH. Isn't it? So when you do the basic hydrolysis reaction, isn't it? To get the carboxylic acid, we need to add H plus at last. Right, we'll take one example now. We'll take one example here. So I am taking here CH3, C double bond O, CH3 I have taken. Right, this is the example I have taken. Is anybody possible on hydrolysis? It may be basic or anything. On hydrolysis reaction, Basic or acidic, OH minus or H plus. H plus means you can add H2SO4. OH minus means we can add NaOH or KOH. These are the reagents we can take for basic hydrolysis, take NaOH or KOH. For acidic hydrolysis, take H2SO4. Now tell me what are the products we are going to have here. Now where we have to break the bond here? Here we need to break the bond. Now tell me where we are getting the product here.
Ethanoic acid plus methanol.
Here we have to add OH minus. So it will be what? Acetic acid or ethanoic acid. Next, this will be what better? This will be what actually?
Methanol.
This will be methanol. Here I am adding hydrogen. So this will be what here? Methanol. Methanol. This will be ethanoic acid or acetic acid. In this way, you can write n number of examples by changing this methyl-ethyl groups. Like you can put here C2H5, CS3, CS2, CS2 like that. There are n number of things. But why this is what very difficult? Because if they ask like this, what happened, then only you are feeling the difficulty. See, actually yesterday I think some of the problems I explained. Some of the problems I explained. So in this case, we'll take one problem here. The third one I will take. So how the conversions looks. I will take the third one. How the conversions will be given in this case. 3-nitrobromobenzene converting into, you see, 3-nitrobromobenzene is converting into 3-nitrobenzoic acid. So this type of problems very important for the conversions. Now what happened here actually? 3-nitrobromobenzene. Now bromo is converting into what here? Benzoic acid. Benzoic acid. That means a halogen compound. How do you convert into benzoic acid? I will explain this one after the class. Okay. After the class means after finishing this topic. 8:45. I will explain this one. Right. Right. This is the very, very important. We will take last this one. Right. Next we move to what? Physical properties. Isn't it? Physical properties. This is the bromobenzene I will take here. Ethyl benzene directly we can convert by using what here? KMnO4. Here also what happens? Same KMnO4. Phenyl ethene also can be done with what? Oxidizing. Same agents we can take for these things. So bromobenzene we'll discuss later how it will be. Next we'll see the physical properties now. The physical properties let me discuss. Now when you observe here what happened, we are discussing about the boiling points from what? Halogen compounds. Okay. So generally what happened, a statement is there like that. We have discussed this one. Hydrocarbon are having less boiling point than what actually? Ethers are having less boiling point than what? Carbonyl. Carbonyls are having what? Less boiling point than alcohol. And alcohol are having less boiling point than carboxylic acids. Carboxylic acids. This is the order actually. Now here we have discussed many number of questions with these examples up to alcohol. Now why carboxylic acids are having higher boiling point? The reason behind this one, because of what? Interhydrogen bonding. Because of what? The higher boiling point, because of what? The hydrogen bonding. Interhydrogen bonding or intermolecular hydrogen bonding. Let me take how it takes place. Now when you observe what happened, how it takes place. So I am writing here what happens, something like this. CH3, shall I take in a PPT? We'll take in a PPT now. How many are there? Only 28. Next, if you observe what happened here, I am writing this hydrogen bonding like this: CH3 C double bond O, isn't it? Shall I write like this? Just a minute. We'll do one thing. C double bond O, OH. Here I am writing what? Any carboxylic acid, RC double bond OH. Then again I am writing here something, R C double bond OH. How many carboxylic acids are there here? How many carboxylic acids are there, beta? 1 and 2. Now here it can form hydrogen bonding here. It can form hydrogen bonding. Because of the hydrogen bonding, it exists as a dimeric. Here you get an important question actually. Now I am asking a question here. What is the molecular weight of acetic acid? What is the molecular weight of acetic acid? Theoretically, what will be the molecular weight? Isn't it? How many carbons are there? 2 carbons. But each carbon carries what actually? 12 as atomic mass. So I am writing what completely what happened. 60 is what? Molecular weight of acetic acid. 24 from the carbon, 4 from the hydrogen, and 32 from the oxygen. Totally we get 60. But experimental studies, if you observe, what happened, the molecular weight you are going to get how much? 120. Why? Because of dimeric nature here. Because of dimeric nature of, isn't it, carboxylic acid. See, it is dimeric or not? See, now it is two molecules are now converted into what here? One molecule. So dimeric nature you are going to get here. Now here one more thing, if you observe here what happened. They all these because of what? Hydrogen bond. This type of thing is not present. Dimeric nature in alcohol also you are having hydrogen bond. But in this case, you are going to get what? Hydrogen bonding. Dimeric hydrogen bonding you are going to get. A dimeric hydrogen bond, which makes a cyclic structure, so that what happen? It is what? Stable. So that is the reason the boiling points will be. Okay, next. This is the dimer. Even in the vapor state also, you can't break these bonds because they are very strong. Generally, what happens when you heat, generally the organic compounds will convert into vapor phase. So all the bonds will be broken in that case. But here, because of what? Dimeric nature, even the vapor phase also, they will exist in the form of dimer nature only. Next thing, if you observe what happens, solubility, if you observe, so as this chain increases, because this is not soluble, this is a hydrophobic character. This is what? Hydrophobic. This will be what? Hydrophobic. And this part will be hydrophilic part. Now, this part never increases here. It will be common for all carboxylic acids here. This will be common for all carboxylic acid. By putting your hydrogen CH3, CH3 like this here, the carbon chains we get increase here. In that case, what happened? When you increase number of carbons, okay, the hydrophobic character will increases, solubility will decrease. You see, the solubility decreases, isn't it, with increasing number of carbon atoms. So this is the thing you need to take. Higher carboxylic acids are generally insoluble in water because of hydrophobic interactions of hydrocarbon. Yet, okay, so this is the thing actually. Benzoic acid, if you observe what happens, is nearly insoluble in cold water because benzoic acid will have here benzene is here. The benzene is what actually here? Hydrophobic character, right? This is about the physical properties. Next, we'll move to what? Acidity, acidic properties. Acidity, if we discuss here. What is the meaning of acidity? Releasing a proton, reacting with a base, releasing a proton, or otherwise evaluation of hydrogen gas. That can be taken as what? Acidity. Now, carboxylic acids are acidic in nature. You can test by what? Litmus paper. Very simple. A blue litmus paper will convert into red litmus paper, indicates it is an acid. Now, how to make these acidic properties? Now, for example, if you observe this carboxylic acid, RC double bond OH, RC double bond OH. This is releasing H plus, RC double bond O minus, plus what happened? H plus. Now, definitely it is acid. Why? Because it is released H plus. Now, how do you know it is released H plus? In that case, what we'll do here, you take sodium here. Take sodium. Sodium undergoing oxidation to give Na plus like this. Na plus an electron like this. Okay, sodium undergoing oxidation to give Na plus here. Now, this electron is taken by whom actually? H plus. Taken by whom? H plus. Now, we are going to get half hydrogen gas. This hydrogen gas indicates this is what? Acid. After this, both will combine here. Na plus and COO minus will combine to give this molecule. So, acids generally, when they react with metals, we are going to get the hydrogen gas. Now, similarly, what is neutralization reaction, beta? What is the meaning of neutralization reaction?
Acid plus base.
When acid react with base, that reaction is called what? Neutralization reaction. Here, what is happening? It is releasing H plus. It is releasing OH minus, right? Now, these two are combining to give water, and this Na plus will take the position here like this. Now, this is a neutralization reaction in which acid release H plus, base release OH minus. We get water and salt we are going to get. Similarly, we can do same reaction with what here? Sodium bicarbonate. So, these are the two reactions, isn't it? Which are taking place with what? Bases. Now, here if you observe what happened in carboxylic acid. If you observe carboxylic acid, after releasing RC double bond O minus will be formed. Okay. If it release H plus, what happened here? You are going to get this structure. Then if it release H plus here, what happened? You are going to get this structure actually. Correct? Now what happened here? Some resonance structures are taking place here to make this one stable here. So what I mean to say is that here, when it release H plus ion, right? You are going to get a carboxylate ion, this one, a carboxylate anion you are going to. And this is what resonance stabilized here. So it becomes stable. Now what will happen? This negative charge will be, isn't it? Will move here and here like this. So this is what a resonance stabilized carboxylate anions, isn't it? So this one can be also explained like this, isn't it? By taking what? Ka and K. What is this Ka and Ka? If you observe here, what happened? Just a minute. If you observe what happened, I'm writing a carboxylic acid here like R. We'll take here. Now I'm writing here like this R C double bond OH. C double bond OH. When it is releasing H plus, what we get R C double bond O minus and H plus. If this reaction takes place, what happened? Then you can call this one acid. Now dissociation constant Ka is equal to concentration of products. This is the product. I'm writing R C double bond O minus H plus divided by RC double bond OH. Okay. Now here the dissociation constant Ka is directly proportional to H plus concentration. If you get more H plus concentration, then the dissociation constant will be, that means the acidic nature of this substance will depends upon what? H plus concentration. More H plus concentration, more dissociation constant. This actually they are saying, you see here this one, isn't it? Now why they taken H3O plus beta? C. H plus or H3O plus, both are what? Same only, isn't it? So here, if you take what happened here, water. If you take here what? Water, isn't it? You will get definitely what happened? H plus only like this, isn't it? Actually, if you write like this only, it will be easy for you. Don't take water. If you take water, what happens? I will show you. RC double bond OH, okay, reacting with water, H2O, that means H plus only, to give what actually? RC double bond O, isn't it? O minus plus, this is taking H plus from here, so you are going to get what? H3O plus. Then if you write what? Dissociation constant Ka, what we get here? RC double bond O minus into what? H3O plus divided by what? RCOOH, isn't it? RCOOH plus what happened? Water. Generally, water does not have any concentration, so no need to take water. So this is actually given in your textbook with taking what? Water. I have taken directly like this here. Both are what? Correct only. Both you can write in examination, no problem. Okay. Now here, what I am saying here, this dissociation constant Ka is depending upon what? H3O plus concentration. Now already you know one thing actually. What is that thing actually? pH. Okay. pH, when it is less than 7, acid, more than 7, base. Similarly, we have a pKa value. Okay. What is pKa value? If you observe what happened. Now already you know pH is equal to minus log H plus concentration. That means pH is inversely proportional to H plus concentration. Similarly, what I am writing here, dissociation constant Ka directly proportional to acidic nature. Isn't it? Just now I told you here. Isn't it? Ka is directly proportional to, you observe here what happened? Ka is here directly proportional to H plus concentration. H plus concentration is nothing but what? Acidic nature. Now, with this what I can write? Ka is directly proportional to acidic character. Isn't it? Directly proportional to acidic character. So what I have written, you see, Ka is directly proportional to acidic character. Now, you know already pKa means, what is pKa? Minus log Ka. Minus log Ka. Right? In that case, pKa is inversely proportional to what? Ka. That means I can write based on this Ka is directly proportional to acidic character. pKa is inversely proportional to what? Acidic character. This is very, very, very important. Nobody asks this formula. Whether it is directly proportional, inversely proportional, nobody asks. Now, how the questions will look here? Let me see this one. This type of questions are asking in examination. You are going to get only this type of questions actually in examination. Like this. Many number of times they are asking these questions only here. right? Now let me see here what happened. Now, if you have some, I'm writing what happened, a carboxylic group like this, R, C, double bond, OH. Now, what I'm writing here, if you have any electron withdrawing groups here, then this will get more acidic character. The acidic character here, what happened here, increases. For example, if you have electron donating groups are there here like this. If you have here what? Electron donating groups, then the acidic character what happen here decreases. So what you have to remember? Electron withdrawing groups will increases the acidic character. Electron donating groups will decreases the acidic character. This is a very important point you have to remember to solve these problems actually. Now I will explain something like this. If you observe what happened, phenyl, iodine, bromine, chlorine, fluorine, cyanide, NO2, CF3, these are having increasing of their electron withdrawing nature. From here to here, what happened? Electron withdrawing group nature is increasing. Definitely what happened? Acidic nature will increases. Okay. Now let me take one example. pH, isn't it? C double bond OH I have taken. pH C double bond OH. Next I have taken CH2. Is it visible for you? What I am writing?
Yes, sir.
Next I am writing what happened, something middle I am writing, CH2F I am writing. CO, I am writing directly COOH, right? No problem, no need to write C double bond OH. Next I am writing what happened, CH2 cyanide, okay, COOH. And what happened, finally we'll take what, NO2 also you can take, CH2, okay, NO2 or CF3, whatever it may be, COOH. Now all are having, you see, CS2COOH, 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 CS2C. Here also you can make CS2COOH also. You can write directly like this, no problem. CH2. C. That means all are what, acidic acids only, but the based on the substituents, you observe here what a phenyl group, iodine, fluorine, cyanide, NO2. Now from phenyl group to NO2, electron withdrawing group nature is increasing, therefore acidic character also will increases. Now in examination, you have to remember this order. Nobody in examination, they don't give the order like this. Compulsory you have to remember. You observe this example, you see. CF3 is high electron withdrawing group, therefore it is strong acid. See, after that we are getting CCl3. And 2 chlorines only, isn't it? Next what? NO2 group. NO2 group. Because 2 chlorines are there. You have to see how many also there are. Of course, NO2 is more electron withdrawing group nature than compared with chlorine. But how many there are actually chlorines here? 2 chlorines are there. So because of having chlorine is a less electron withdrawing group nature when you compare with NO2. So what happening here? Because of this, what happened? Because of 2 halogens here, it is now more than what? NO2 group. Now you see NaC like this. See fluorine, isn't it? Like this. Finally, we are going to get this one. So this order you have to practice, everyone. All of you, today homework is what here? This is the homework for you. Today's homework is what? You in your notebook, what happened? Write down this one. Write down this order in your notebook. Okay. And so that you will get easily understood which is strong acid and which is weak acid. You have to follow this order. You have to follow this order actually. And one more exercise will be what? Esterification. Esterification is one exercise you have to practice today. Esterification, because in examination point of view it is important, and this one also important. Next, if you observe what happened. Now, when you observe what happened, this is actually no need for you. Generally, because they denotes, that is the reason what happened, the decreasing of acidic character will takes place. Now, here important thing is that All are what? Benzoic acids. Now you see here, OCS3 is electron donating group because it donates electron. It's a which type of group beta? Plus mesomeric effective group. To know what are plus mesomeric and minus mesomeric, you go through what? 11th class, isn't it? What I given in that notebook, you read that one. In the 11th class notebook, you read that one, you will get. Next, NO2 group is electron withdrawing group. It is minus mesomeric effect group. This is what? Electron donating groups. I told you already, presence of electron donating group will decrease the acidic character, right? Presence of electron withdrawing groups will increase the acidic character. Now, thing is that they are asking pKa order. If they ask pKa order, what we have to write? pK order? Decreasing of acidic character. If they ask what happened, pKa, decreasing of acidic character. Because pK is inversely proportional to acidic character. Remember, you observe here, pKa value how much here? 4.46. Here it is 4.193. That means higher the pKa, lower the acid. This is what actually higher the pKa, you are having high value here. So this for it is less acidic. The acidic strength will be less acidic. Now here I am having low pKa value. It is having what? Low pKa value means what is more acidic in nature. So understood, I think. Everyone is understood, I think. So why it is what? Strong acid, why it is what? Weak acid. Isn't it? Based on the pKa values, you can say. Next, let's go to what? The chemical reactions involving where the bond is cleaving here, COH bond, something like this. CS3, if I take what happens, C double bond, OH, the bond is breaking. If the bond breaks here, that is acidic property, already we completed that. Now we are breaking what? Bond over here. Now in this case, what happened? This is very important for conversions reaction. Very important reaction for conversions here. How to make this reaction? Very simple I will make here. Very simple I will make. You see here. Very simple it is. Now what I am writing here, CH3, isn't it? C double bond OH. Right? Take another mole, reversely you take here. Take another mole, reversely like this. C double bond O, CS3. Take reversely like this. Both are acidic acids only. Now remove the water, join these two here. When you remove water and join these two, what happens? You are going to get CH3, C double bond O. Next, what happened? Oxygen, then C double bond O, CS3. This is called what? Anhydrate. So what you have taken? Ethanoic acid, no? You have taken what? Ethanoic acid. Therefore, it is called what? Ethanoic anhydrate. It is called what? Ethanoic anhydrate. Right? Here it is given this. It is also called acetic acid also. It is also called what? Acetic acid also we can call this one. So you can call this one now acidic anhydrate. If you call acetic, generally we use acetic anhydrate only. To get this type of reaction, the reagent we are using dehydrating agents, which removes water. What are they? Concentrated sulfuric acid, and we can also take P2O5. Generally they take P2O5. These two are the reagents which removes water from what? Carboxylic acids. So it is very important in conversions. Carboxylic acid will convert into anhydrate. Right? Next we'll move to what? Esterification reaction. How to make esterification reactions, isn't it? So we'll see this one, esterification reaction like this. R, for example, if I take R, isn't it? C double bond OH. Okay. Now, here you take alcohol in the reverse way. Take alcohol in the reverse way like this. Now, what we'll do here, remove water between these two. Remove water between these two. Now, what we're going to get here? R, C double bond O, OR. What we are going to get? Ester. Ester. So, what are the reactants here? Carboxylic acid. Carboxylic acid reacts with alcohol to give here esters. This is what actually reaction. Carboxylic acids with alcohol will give ester. You take your R dash, you will get R dash. Now this is the mechanism. First you are adding H plus to where here. So that what happened? You are going to get H plus here like this. Then alcohol attacks here. ROH will attack here. So this bond will be shifted over here. And after that, what happened? This bond also will be shifted. I told you many number of times, carbon which is having two OH groups highly unstable. So you can break this bond here and remove this OH here. You will get this one. Okay. So this is the mechanism you can practice. It is shown in that one. It is very simple. Next, what happened? We'll see reaction with PCl5 and PCl3 SOCl2. This already we discussed where in the halogen compounds reaction. Now, what happens if you observe? When you take PCl5, PCl3 or SOCl2, this OH group is converting into what here? Cl. Only this is happening. The OH group is converting into your what? Cl. Isn't it? COCl, isn't it? Here also, the OH group is converting into Cl like this. This is happening. Very simple here. And I told you when you take PCl5 in halogen compounds, I told you we get POCl3 and HCl as a byproduct. When you take PCl3, we get H3PO3. When you take SOCl2, we get SO2 and HCl. And which is the best method also I told you? This one is the best method because the byproducts are what happened? Gas molecules. This already we discussed where in the halogen compounds. Very simple. The OH is what? Replaced with what? Cl. So very simple. OH converting into what here? Cl. In this way, we can easily remember. Useful in the conversions only. Now, let me take reaction with ammonia here. Isn't it? Reaction with ammonia. We'll complete only the reaction with ammonia. Remaining we'll discuss tomorrow. Right? Only the ammonia is very simple reaction. No need to practice more here. Very simple. Add NH3 completely to this one. Now what we get here? NH3 will convert into NH4. So here it is very simple. No. NH3 we are adding to this one. We are going to get what? CH3 COO NH4. Correct? After this, when you heat this one, here it is important for you. This is very, very important. Here also it will be useful in the most of the conversions we get from this chapter only. So CH3 COO NH4, how we got amide here? Let me discuss this one. CH3, okay, COO NH4 I got. And this is converting into what? Amide. How? How it is converting into CH3 CO NH2? Very simple. Remove water from this one. Now remove from this one 2 hydrogens and remove 1 oxygen. And remove one. That means you are removing water. It is nothing but dehydration reaction. Now, after removing this oxygen, you got only 1 CO. After removing 2 hydrogens, you got CONH2. Amide you are going to get. Amides you are going to get. So, what I am saying here, when carboxylic acid react with ammonia, we get ammonium acetate. We get here. On dehydration, with the removing of water molecule, we will get amides. If it is acetic acid, we get acetamide. Ethanoic acid, ethanamide, you will get. Now, very simple. You can take benzoic acid here. Benzoic acid means you can write like this also. PH C double bond OH. Now, when you add NH3 to this one, now what we are going, both will be added here. So, we PH C double bond O NH4, sorry, ONH4 we get. ONH4 we get. ONH4. Okay. After this, what happened? Remove water molecule minus water by heating this one. What you have to do? You have to heat this one, but high temperature. On heating, you have to do no reagent. Simply, what happened? You have to heat this one. Now, remove oxygen. Remove 2 hydrogens from this one. Now, what we get here? PH C double bond O. NH2. This is called what? Benzene. No, penal is nothing but benzene. This one is what? Amide group. No. So it is called what? Benzamide. You can call this one. Benzamide. Okay. Amide group with benzene. So benzamide it is called. So these are the reactions involving their breaking of C double bond OH bond. Here we are breaking it. Here we are breaking. With this, what happened? This topic is completed. Next, in the next class, we'll see the reactions involving in the COOH groups. Now, for example, if I take this molecule, how many OH groups are there? 2 OH groups here, 2 carboxylic groups here. So here ammonia will attack, and here also here ammonia will attack. So we got same thing here, same thing. After that, when you take what happened? Water. Now minus H2, remove oxygen. Minus H2, remove oxygen. You are getting what? Thalamide you are getting like this. Thalamide. After this, how we got this thalamide? Let me see. I'm writing this one. How you got? You take like this here. C double bond O, NH2, C double bond O, NH2. Now, lone pairs are there here, no? Lone pairs. They are attacking on the C double bond O and NH2 is removed here. Right? Now, what we get after this one? You see, C double bond O, next NH2, here it is the C double bond O like this. Now, once lone pair given to the carbon, this nitrogen will get a positive character. Now, what happens here? Bonding electrons are taken by this one. Therefore, NH2 minus and H plus ammonia will be removed. You are going to get this product. This is the preparation of thalamide. You practice this one. Preparation of thalamide, you practice this one in your notebook. So, whatever we are writing, whatever I am discussing, you have to write in your notebook compulsory. Whatever I discuss, everything you have to write in your notebook. Along with that one, I told you some exercise you have to send me. What are I told you? Just now I told you some exercise. What are they actually? This one, carboxylic acid. This is esterification and this part. Compulsory you have to show in assignment, right? With this, what happened today, class is completed. Now, if you have any doubts, you can ask me now. If you have any doubts, you can ask me now.
Sir.
Bola better.
Sir, what are aprotic solvents?
Aprotic, protic, two solvents will be there, right? I will show that, no problem.